Hello friends, welcome to my channel. In this video I am going to show you how to do class A subnet calculation. Given IP address is 10.0.0.0/11. First of all, we need to identify the class of the given IP. Here the first octet in the given IP address 10.0.0.0 is 10, which belongs to class A. You can find from the table that the default subnet mask of class A address is 255.0.0.0. Our next step is to convert the default subnet mask into binary. Please remember that all the ones are network bits and all the zeros are host bits. Here /11 notation in the IP address is the CIDR notation, that is classless inter-domain routing. /11 means 11 bits are used in the network portion of the subnet mask. In the default subnet mask, there are 8 bits in the network portion and 24 bits in the host portion. We need 11 bits in the network portion as per our IP address range. In order to make it 11 bits, we have to borrow 3 bits from the host portion. For your reference, the decimal values of each binary bits are shown here. To get our new subnet mask, just add the decimal values of each octet and we get 255.224.0.0 as our new subnet mask. Increment value is the decimal value of the lowest ones bit in the borrowed bit. This value is incremented to find the next subnetwork. Here we have borrowed 3 bits from the host portion to make the slash notation. Hence the increment value here is 32. Network ID is the first IP address on every network. Broadcast ID is the last IP address on every network. The usable IP address are those IP addresses which can be assigned to host that comes in between the network ID and broadcast ID. Our first subnetwork ID is 10.0.0.0/11. Since the increment value we got is in the second octet, we add the value 32 to the second octet to get our next subnetwork ID. Keep on adding the increment value 32 to the subnetworks until 255. We know that the IP address range is from 0 to 255. As you can see, the last network ID is 10.224.0.0. If you add 224 with 32, we get 256. Since 256 is not a valid IP address range, we will take 224 as our last subnetwork ID. As you can see here, there are 3 ones and 21 zeros here. Since the bits were borrowed from the second octet, we will count from the second octet only. So the total number of networks available is equal to 2 raised to n is equals 2 raised to 3 equals 8 networks. Total number of hosts available equals 2 raised to h minus 2 equals 2 raised to 21 minus 2 equals 2,097,150 hosts on each network. I hope you all understood the video. Please do like, share and subscribe. Thank you.